the universe will not keep expanding forever. It will freeze to death. Scientists have already calculated the time of the universe's death. It will be 10 to the power of 100 years from now. By then the entire universe will completely go dark. No light, no heat, no events happening at all. Even time itself will lose its meaning. Every star you look up and see right now is the universe's final afterglow before death. And we happen to be living in the universe's most glorious childhood. Stars are being born. Galaxies are colliding. Supernovae are exploding. But just like all stars eventually die, the universe itself is also moving toward an end. A future with no light and no heat, unable to sustain any form of life. This end is called the Big Freeze, also known as the heat death of the universe. To understand why the universe will freeze to death, we must first return to the moment it was born. 13.8 billion years ago, the universe was born in a Big Bang. At that time it was extremely hot, extremely dense. All radiation and fundamental particles were compressed into an extremely small space. Then the universe began to expand. The temperature began to drop. The first atoms formed. The first stars ignited. These stars fused hydrogen into helium, releasing enormous amounts of energy, lighting up the entire universe. They were the first power plants to create order out of chaos. But here is a key concept that determines the fate of the universe. That is entropy. Entropy is a measure of the degree of disorder. If an ordered system lacks energy to maintain itself, it will spontaneously move toward disorder. A cup falls to the ground and shatters, but the pieces will never reassemble themselves. The universe is the same. Every star, while shining, is consuming the possibility of maintaining order. It turns highly concentrated fuel into dispersed energy and particles. The universe's fuel reserves are being gradually used up, and those reserves are finite. At the same time, the universe is not only evolving, but also expanding, and this expansion is accelerating. Driving it is a mysterious force called dark energy. We do not know what it actually is, but we know what it does. It makes the distances between galaxies grow larger and larger, and at an ever-increasing speed. This means that in the distant future, all galaxies will become isolated from one another, so far apart that they can no longer see each other. If there are still observers in the Milky Way, then the universe they see will appear very small, very dark, very empty. Even though trillions of stars still exist scattered everywhere, they will never be able to contact each other again. But the bigger problem is, these stars will also die. Their fuel is not infinite. The first to die are the massive stars. They end in spectacular explosions, leaving behind black holes or neutron stars. Then come medium-sized stars like the Sun. They expand into red giants, and eventually become white dwarfs, stellar remnants with no nuclear fusion, that only cool down slowly. The last remaining stars are red dwarfs. They are the longest-lived stars in the universe, able to burn for tens of trillions of years, but even they cannot escape the fate of extinction over an unimaginably long timescale. All red dwarfs will exhaust their fuel and go completely dark. By then the universe will enter an era with almost no new stars being born. The night sky will grow darker and darker. All that remains will be stellar corpses, white dwarfs, brown dwarfs, neutron stars, black holes. White dwarfs will continue to cool, their radiation growing ever weaker, eventually becoming nearly invisible black dwarfs, cold masses of dead matter drifting through space, with no light at all. The time required for this cooling process is far longer than the current age of the universe. Meanwhile, galaxies are also undergoing another kind of evolution. Gravitational interactions fling many stars out of their galaxies, and the black holes at galactic centers continuously devour gas and stars. Even other black holes, growing larger and larger. In an extremely distant future, almost all matter in the universe that can still interact will be swallowed by giant black holes. This is the black hole era. Black holes will become the final protagonists on the cosmic stage. Even at this stage, energy activity still exists. Black hole collisions generate intense gravitational waves. Matter releases energy before falling into black holes. But compared with the vibrant, youthful era of a universe filled with brilliant starlight, this is already an aging and exhausted universe. However, even black holes are not eternal. Physics predicts that black holes lose energy extremely slowly through a mechanism called Hawking radiation, gradually leaking energy on a timescale so long it is desolate. Even the largest black holes will eventually evaporate completely, releasing their mass in the form of extremely faint particles. After all of this happens, the universe will enter an even more extreme stage of emptiness. At that time there will be no stars, no planets, no black holes. Only a soup of extremely sparse subatomic particles will remain, mixed with some very low energy photons, and perhaps some exotic matter we do not yet understand. entropy will reach extremely high values. There will no longer be any processes in the universe capable of creating new complex structures. Everything will be dispersed, cold, and uniform. This is heat death, a state in which the universe reaches near perfect thermal equilibrium. There are no longer significant temperature differences between regions. Without temperature differences there is no energy flow. Without energy flow there is no work, no chemical reactions, no life. Time still exists, but no new events will occur. Like a clock, the dial is still there, but the mechanism stopped long ago. From the perspective of physics, this is a natural ending. The second law of thermodynamics, the law stating that entropy must increase, has been faithfully carried out on a cosmic scale. The universe has gradually exhausted its ability to sustain complex processes, until only endless cold and absolute silence remain. Of course, these predictions are based on our current understanding of the universe. If the nature of dark energy is different from what we think, the ending may change. Some models suggest the universe will experience a big rip, with expansion accelerating until atoms and particles are torn apart. Other older theories say the universe will undergo a big crunch, collapsing back into a dense point. But based on our existing observational data, the big freeze is the most likely outcome. So what does this mean for us? In fact, on the human timescale, all of this is almost meaningless. The heat death of the universe is far too distant from us, so distant that Earth, the Sun, and even the entire Milky Way will disappear long before then. But from another perspective, this understanding changes how we view the present. We live in an extremely special period in cosmic history. The universe is still young enough. Stars are burning everywhere, galaxies are actively operating, planets have stable conditions, life has a window to emerge and evolve. For a civilization that can look up at the stars and ask how all of this will end, now is the most interesting and dynamic moment in the universe. The starry sky you see is a fleeting privileged image in the history of the universe, a gap between the blazing chaos of the beginning and the icy silence of the end. And we, these lives capable of contemplating the fate of the universe, are themselves a fragile miracle, supported by a series of rare physical, chemical, and astronomical conditions. Knowing that everything will eventually end does not make the present moment meaningless. On the contrary, it makes the fact that we exist right now feel heavier with significance. The universe will not remain friendly to life forever, but as long as this window remains open, we have the chance to observe, to study, to understand this grand stage we inhabit. The Big Freeze is not just a cold prophecy about absolute zero. It reminds us that everything is evolving. Nothing is static. Even the universe itself has a story, with a beginning and a middle, and a very, very distant ending. And no matter how dark that ending may be, the fact that we can tell this story here is itself already something astonishing.